All right, today we're going to talk about relations, domain, and range. I know that several of you have quite a bit of homework to do tonight, and or not really quite a bit. That worksheet that I gave you for homework tonight shouldn't take you very long, but I know you do have homework, and I want to keep this video as short as possible. Before we get started on this video, though, I do want to tell you, first and second period, great job on getting those activities done this morning and getting your bell ringer worked out. You guys are doing a great job. Also, if you're watching this video right now and you haven't printed out the notes, it's best if you print out the notes and follow along, because all I'm doing is going through the notes with you like I did in a previous video, but this one will be a little bit quicker. If you're watching the video and you can't print the notes out, that's okay, but I would recommend that you come in the morning, get a copy of the notes, and then watch the video again in the morning so that way you can have these notes for you to study at a later date. Okay? It's very important that you study as much as possible with all the resources available to you. Okay. So relations, domain, and range. A relation, definition, a vocabulary word, is a set of ordered pairs. Okay? Relations can be expressed in 4 different ways. Obviously, we can use ordered pairs. We can use mapping. It's my least favorite, and to me, not as useful as other things. We can use table. And we can even use, of course, graphs. Now, I don't want you just to think about this and say, okay, I got to memorize that relations can be expressed in 4 different ways. I want you to understand what I'm talking about here. Ordered pairs are obviously ordered pairs. Mapping, they create ordered pairs. If you remember the 2 circles with the 2 ovals and you have numbers in between with the arrows drawn to them, those are creating ordered pairs. Tables create ordered pairs. We use tables to create ordered pairs in order to graph them. Graphs are filled with ordered pairs. That's what your line is, a whole bunch of ordered pairs with a line drawn through it. That's what a graph is. Don't just say, I got to memorize this. Understand, these all deal with ordered pairs. Okay? Let me go ahead and move this up. Okay, so let's represent the relation shown in the coordinate plane. So in the coordinate plane, if you have your notes in front of you, surely you can see there's dots here. I'm going to make them a little bit brighter for us to see on the video. But you have several points here. So the first thing I want to do is I'm going to create my ordered pairs, because that's what it says, a set of ordered pairs. So I'm going to work from left to right. The left set, whenever I have ordered pairs, I need to put them in parentheses. I have -1, 2, 3, 4, 5, -5 over, and 1, +1 up. So my ordered pair is the x first, -5, and 1. Always do your x, y. It should go x, y. Okay, my next one is -1, 2, 3 over, and down now, so down means -1, 2 down. So -3 over, -2 down is my next ordered pair. Okay, my next one is -1, 2 over, and then -1, 2, 3, 4, 5 down. So -2, -5. Okay? Then I have a point right here on my origin. My origin is always 0, 0. Okay, and then I have a point going 1, 2, +2, and up 1, 2, +2. So then I have a point at 2, 2. Another point at 1, 2, 3, 4, +4 over, up 1, 2, 3, 4, 5, 6. So I'm going to come down here, 4, 6. And then my last point right here is 1, 2, 3, 4, 5, +5, and down -1, 2, -2. So 5 negative 2. Okay, so that's the set of ordered pairs. That should have been pretty simple. All right, now, let's go ahead and create a table. If I was to create a table, I'm going to take all my x values and put them in my x column. Again, those are my independent values. That's where we're going to find our domain in just a minute. So my x values are, I'm going to put them in numeric order. Okay, so I'm going to put them in numeric order with the smallest one first, working my way to the largest one. You don't have to necessarily. It's just better. It's easier to organize. So my highest one is negative 5. And this should already be like that because of the way we went. So I have negative 5, negative 3, negative 2, 0, positive 2, 4, and 6. I'm sorry, not 6. 4 and 5. So hopefully you can see that. And those are all my x values. On the other side, I'm going to put my y values. So those are all the second numbers in the coordinates. So I have 1, negative 2, negative 5, 0, 2, 6, negative 2. They have to go with their specific x values. You cannot reorder y without reordering x. So negative 5 and 1 must go together. Negative 3 and negative 2 must go together. And y, again, is our dependent side and our range, which we're going to talk about in a minute. Take a second to make sure you have that written down. If you need to pause the video because I'm going to erase now so I can move the mapping better into better view. Okay, so when we map, we have the same, if we use the same data set, okay, and I know that mine is erased now, so I have it written down on my iPad here, so we'll use yours, and again, you should have it written right above in the ordered pairs. When we map, we write down the same thing. Negative 5, negative 3, these are our x values, negative 2, 0, 2, 4, and 5. Then I write down my x values in the same form this time. This time I'm not worried about matching them up necessarily. I'm going to go from least to greatest. So in this case, I'm going negative 5, negative 2, 0, 1, 2, and 6. Okay, now I've got them matched up. I have them written from least to greatest. What I want to do now is draw my lines connecting the x and y values together. So for negative 5, I should have a positive 1. So I'm going to draw my line to positive 1. For negative 3, it's negative 2. So I'm almost going to draw it straight across. Negative 2 is negative 5. 0 is 0. 2 and 2, straight across. 4 and 6, straight across. And then I have 5 and negative 2, which is way up here. Okay? And it's okay that negative 3 and 5 have the same y value. I do not rewrite negative 2 twice. I know it's used twice, but I just draw up 2 arrows to that. Do not rewrite negative 2 twice just because it's on there twice. See, if you can see mapping, if I map this way, okay, if I take my order pairs and then I map, it's not as convenient as the other things like writing a table or something else. So usually we don't use mapping a whole lot unless we're trying to figure out the order pairs. Okay, quickly moving on. The next thing says, and I'm going to move this up just a little bit so I can get all the words in there. And this should finish out your first page. It says the domain is the set of what? Well, we just said it a second ago. I just said it. I don't know if you caught it. But it's the set of the first coordinates. That's why there's 2 blanks there. In a relation. Now remember, relation means ordered pair. So what is the first coordinates in every ordered pair? Well, that's all of the x's. That's all of the x's. So what's the domain from our example up here? Well, it's all the x values. You would write it like this. Domain, dot, dot, and then you have a bracket. And then you need to write all of your x values. So all of your x values are -5, -3, -2, 0, 2, 4, and 5. Okay, so that's all of your domain. So if domain is all your x values, what do you think range is? That's right. Range is the set of the second coordinates in a relation or an ordered pair. And all the second coordinates, if x is my first coordinate, all the second coordinates are all of the y's. So that's all my y values. So I would write range almost like domain, except instead of D, I'm going to write R, dot, dot, bracket, okay, -5, -2, 0, 1, 2, 6. Close brackets. Now again, pay close attention. I know that -2 is used 2 times. You don't have to write -2 twice. It is going to be incorporated or encompassed already by the first coordinate or the first order pair. I have seen worksheets, tests, tax tests, STAR tests that will write that, rewrite that, but it is not necessary. It is not necessary. So go ahead and get all those down as we move on to the second page of our notes. If you need to pause the video while I erase, pause the video. Okay. Now we're going to talk about functions. We just talked about relations and we talked about domains and range. Now we're going to talk about functions. I'm going to scoot this down just a little bit. Okay, so the top of your notes, it says a function is a relation in which none of the first coordinates repeat. Okay, none of the first coordinates repeat. We've already talked about this a little bit in class as it is. So all of the x values are different. I like to tell my students, and I have in years past, for every x, there is only one y. For every x, there is only one y. If you have 2 y's, that means your x has to repeat, which doesn't make it a function anymore. Okay, so if we look at an example, so state the domain and range. Then determine whether or not the relation is a function. Okay, so let's look at the domain. The domain are all my x values. X, 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 and x. So my domain is equal to 2, 3, 6, and -1. Some people also will write this in numeric order. It's more proper to write -1, 2, 3, and 6. That's just from least to greatest. And then all my y values make up my range. So here's my y values. Y, 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 and y. So then my range is 4, 5. We don't have to write the second 5, so we can skip that. And then 3. Whoops. And again, some people put these in order from least to greatest. So then you would have 3, 4, and 5. So let me ask you this. Is it a function? What are we looking at? Are we looking at the range or are we looking at the domain? Well, we're looking at the domain, the x values. Do any of the x values repeat? Well, 2, 3, 6, -1. I only set them all once, so none of the x values repeat, so yes, this is a function. No x value repeats. Okay, take a second to get down that information. If you need to pause it, go ahead and pause it while I erase and move it up. Here's another example. Why don't you pause the video for just a second and do this one on your own? Okay, hopefully you paused and now you're coming back. So here's our domain. Again, all of our x values. If I put them in order from least to greatest, here's my x value. I got a -2. -4 is my greatest. Okay, so I'm going to start with my least, not greatest, my least. So -4, -2. Then I go down to 1. My 1 repeats. I don't have to write it, but it repeats. There it is. And then I go to 2. That's my domain. My range is all my y values. I have a 9, a 5, a 6, -3, and 8. Again, if I write this from least to greatest, my lowest one is -3. Then I have 5. Then I have 6. Then I have 8. And then I have 9. So there's my range, my domain of range. You should have already figured out that it's not a function because in my in my coordinates, I see that the x value 1 repeats. Because it repeats, it makes it not a function. It is not a function. Notice none of my y values repeat, but that does not have any bearing. It's only my x values I'm concerned with. Make sure you get that information down. Okay, this is information that you need to know. It's very important. All right, now let's look at our last example. Example 4 says express a relation shown as ordered pairs, state the domain and range, then determine if it is a function. Now this is where I see mapping used more frequently. So let's create ordered pairs from the mapping. Well, you have an arrow going to 2 and 12. So my first one is 2, 12. Remember, this column is our x column. It's stated right here. This is our y column. Okay? I also have an arrow going from 2 to -3. So let's write that down. So 2, -3. Then I have an arrow going from 1 to 5. So 1, 5. Then I have an arrow going from 0 to 0. So that's the E. You tell me what is 0, 0? Should have said origin. Okay? And then I have an arrow going from -1 to 5. So there are our ordered pairs. You should have 1, 2, 3, 4, 5 ordered pairs, all based on the lines that you see connecting the x and y's in the map. What's our domain? Well, it is all my x values, so when I have mapping, this is really easy. I can go ahead and do this right away. Domain, so D, dot, dot, brackets, all my x values. If I put them in order from least to greatest, I have -1, 0, 1, and 2. That's pretty simple. Range is even just as easy as the domain. All my y values. So here's my domain. Here's my range. Now, do not get lazy on homework or assignments or tests and just try to write D and R. You need to write it in this format always. Okay? So my range is R, dot, dot. Okay? Write it from least to greatest. You have -3, 0, 5, and 12. Pretty simple. Pretty simple. At this point, you should be starting to identify or see quickly if it is a function or not. So, I'm not going to move the paper up anymore. I'm just going to let you look at that data. You tell me, is it a function? It is not a function because, look here, 2 repeats. If you look here, you have 2 arrows, one going from 2 to 12, and one going from 2 to -3. Because it's got 2 arrows, it is not a function. My x value repeats. It is not a function. Okay, so that pretty much wraps it up for us for domain and range. Again, guys, you've seen this before. We've talked about this before. We haven't really talked about domain and range a lot, but it's a pretty easy concept. But we have talked about if it's a function or not a function. We've talked about ordered pairs, x's and y's. You just got to put this into memory. So I'll see you tomorrow in class. Need to be prepared and ready to go so that we can have as much fun and take care of as much business as we need to each day. Again, I appreciate all the hard work you guys do.